if u equal to 1, 2, 2, v equal to 2 minus 2, 1, and once again minus 2, 1. U equal to this much. If u equal to 1, 2, 2, and v equal to 2 minus 2, 1. Find the lengths of u, v, and also normalize the vectors. Such that the two vectors are orthonormal vectors. Okay, so here if u v is equal to this, then you need to find the lengths of u v and also normalize the vectors. See, if you find no, you will understand whether it is those are unit vectors or not. If they are not unit vectors, then you need to normalize the vectors such that the two vectors are orthonormal vectors. Okay, so see, those who can solve on your own, you can do that. Okay, we'll see the solution. So u is equal to 1, 2, 2. B is equal to 2 minus 2, 1. Okay, so first we'll find the length. So u equal to, it's nothing but under root of 1 square plus 2 square plus 2 square. It's nothing but under root of 9. It's nothing but 3. So it is not unit vector. Okay, so you need to normalize it. Okay, so let me consider u n is the normalized vector. So un is nothing but u by mod length of u. Okay, so it's nothing but 1, 2, 2 by 3. So it's nothing but 1 by 3, comma 2 by 3, comma 2 by 3. This is the normalized vector. Okay, and what is the other vector you have? V. V is nothing but, if you try to find the length of un now, it will be equal to 1. Okay, you can just check. If you have any doubt, you can just check. It will be the unit vector. Next, v is equal to 2 minus 2, 1. 2 minus 2, 1. Okay, again you find the length of this. It is under root of 2 square plus minus 2 square plus 1. So again, if you find, it will be root 9. It is nothing but 3. So this is also not the unit vector. So let me consider the normalized vector is nothing but Vn, which is given by V by length of V. So V is nothing but 2 minus 2, 1 divided by 3. So it's nothing but 2 by 3 minus 2 by 3 and 1 by 3. So these are the normalized vectors. Okay, so since I have normalized it, those are unit vectors. The first condition is okay now. And what about the second condition? Second condition is nothing but, so this is the first condition. We made them as unit vectors. And here what is asking? Find the length of u and v, and also normalize the vectors such that the two vectors are orthonormal vectors. Okay, orthonormal vectors means the first condition un, and the first condition is un is equal to 1. Length of un is nothing but 1. Length of vn is also nothing but 1. Okay, after that I've got. What is the second condition? The dot product between un and vn should be equal to 0. Okay, so how do you calculate un dot vn? It is nothing but un transpose into Vn. Okay, Un transpose. Un is what? Un is 1 by 3, 2 by 3, 2 by 3. Usually we'll write it in this way, right? Column vector 1 by 3, 2 by 3, 2 by 3. So the transpose of this is nothing but 1 by 3, 1 by 3, 2 by 3, 2 by 3 into V. Vn. Vn is nothing but 2 by 3 minus 2 by 3, 1 by 3. 2 by 3 minus 2 by 3, 1 by 3. Multiply these two. So it's nothing but 2 to the 1 by 2 into 1 by 3, 2 by 9 plus, not plus, it is minus 2 by 3 minus 4 by 3 plus minus 4 by 9 plus 2 by 9. Okay, so take the LCM. 2 minus 4 plus 2. So 0 by 9, it is nothing but 0. So since both the conditions are satisfied, the given vectors are orthonormal vectors. So you may have a question like why orthogonal or orthonormal vectors are required. Okay, in practically why it is required. Okay, so during communication. Okay, so during communication, what happens is like we'll be sending so many signals by modulating it through the same channel. Okay, so in that case, what happens? We need to have orthogonal signals, orthogonal carriers. Okay, so in order to generate this orthogonal carriers, we'll be using we will be finding the orthonormal and orthogonal vectors. So like we'll check whether those whatever see, you all know how the modulation will be done. Okay, so let me just take one small circuit. I have some message signal I have. I will modulate it and I'll send it through the channel. This is the modulator. I'll send it through the channel. This is M1. This is one more signal M2. I'll have the modulator and I'll send it. Okay, then what I'll do, I'll try to send all the signals through the same channel. Okay, so here I'll be using the carriers to modulate the signals. We'll be using the carriers. Okay, so don't worry, even if you're not understanding, it's fine because we'll study all this in detail in your higher semesters. Okay, here I'm just giving you, you might be thinking like why all these are required. Okay, so that's the only reason I'm just giving you some hints here. Okay, so here you have the modulator. So your modulator, what it will do, it will modulate the message signal and it will transmit it through the channel. Okay, so here I'm using the carriers. Okay, so these carriers, whatever carriers I have, they should be orthogonal to each other. Okay, so since to generate this orthogonal vectors, we have different procedures. Okay, so the main thing is we'll use it in the communication systems where we'll be using the orthogonal carriers to transmit the signals from transmitter to the receiver. Okay.